Okay, let's have a look at this question here. Okay. Z is x plus iy. Okay, so prove that z1 plus z2 conjugate equals. Okay, so that would be x1 plus iy1 plus x2 plus iy2 conjugate, which is x1 plus x2 plus y1 plus y2 I conjugate, which is x1 plus x2 minus y1 plus y2 I, which is x1 minus y1 I plus x2 minus y2 I, which is x1 plus y1 I conjugate plus x2 plus y2 I conjugate, which is equal to z1 conjugate plus z2 conjugate. And obviously the logic applies when you add three of them together. So I don't think there's much more to say really for this first part. You're told that z1 is a root of that cubic. Prove that z1 conjugate is also a root. Oh, very good. I haven't seen this now in a while. I started at 2021 this last few weeks. So yeah, okay, it's the first time I've seen them ask you to prove the conjugate root theorem. I wonder if I remember it. So you have z1 cubed plus a z1 squared plus c z1 plus d equals 0 since z1 is a root. So using the previous result by conjugating everything, z1 cubed conjugated plus a z1 squared conjugated plus c z1 conjugated plus d conjugated equals 0 conjugated, which is 0. Now, the only thing here, which I'm assuming that you're allowed to do, is to say that this is now z1 conjugated cubed plus a z1 conjugated squared. Now, because a is real, it's conjugate. I mean, you conjugate it, nothing happens if it's real. So since a conjugate equals a if a is real, and also z1 z2 conjugated equals z1 conjugated z2 conjugated. So you can see, therefore, z1 conjugated is a root. Okay. Let's see what's next now. Find a and c, and we have one of the roots. Okay. So one root is 1 plus 2i. So therefore the other root is 1 minus 2i. The sum of the roots is 2, and the product of the roots is 5. So that means you can say z cubed plus az squared plus cz plus 5. That's going to have a quadratic here. It's going to have z squared minus 2z plus 5. The 5 is good. The plus 5 is good here because the cubic ends with a plus 5. I know that this guy has to be a plus 1. And the cubic starts with a z cubed, so I know that it has to start here with a z. So just multiplying this out would have me done. That would be z cubed minus 2z squared plus 5z plus z squared minus 2z plus 5. So that's z cubed minus z squared plus 3z plus 5. So the a is minus 1 and the c is 3. So the a is minus 1 and the c is 3. And we do get the 5 at the back. Okay. Z cubed minus z squared plus 3z. Yeah, okay, that's the first part done. Oh, I think I must have cut off the information about the transformation. Let me get it. What did I cut off? 1983. Oh yeah, cut it off. Why did I do that? That's the transformation there. Okay, so what's the transformation here? Okay, we can do it in steps. Z, first then you conjugate it, then you minus it, then you add on the original. Maybe there's too many steps here. I think there's too many steps. Might want to do it as a formula. Okay, that might be best. Oops, knocked my pen out. Okay, so let's see. U plus IV, that's the new point. That's equal to I over 2 x plus iy, and then minus the conjugate, so that's minus x, and it'll be minus, so it'll be plus yi. Oh, that's interesting. They cancel, and then there's two of them here, but you can cancel like that. So I squared is minus, so it's going to be 0 minus, it's going to be minus y, is it? That's interesting. So that means u is minus y and v becomes 0. So there is 2 and there is 4, and the distance between z and 2 and z and 4 have to be equal. So I think it's just this vertical line here, that's k, and it's at it's the line here at 3. I think it's just a line, although yeah, I think so. So the transformation of it would be So if I took, for example, the point 3, like for example 3 plus 0i, you would get 0 plus 0i. What about if I took 3 plus I? So the u is minus, so that's minus 1 plus 0i. What about if I took 3 minus I? The u, okay, so that's 1 and then plus 0i. So it just looks like it becomes the real axis. So I think what's interesting about this is this part here, the z minus its conjugate divided by 2. So that's going to cancel the real components, leaving on the imaginary component. And then we multiply by I. So it rotates at 90 degrees. Yeah. So I think that's it. I think that's it. Yeah, okay. I'm not very confident about that last part, but I think that's it.